Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will talk about the integrity constraint while maintaining queries in SQL. How to maintain integrity constraint, what is an integrity constraint, and where to use the integrity constraint in the SQL. We will see different cases like the referential integrity, the check consent integrity, as well as the assertion integrity in the SQL with examples of each. First, we need to know that what is constraint. Say for an example, we know that one instructor cannot have the same ID with another instructor. Or say that a department budget cannot be greater than or equals to $0. Or we can say that two of the departments on two instructors cannot be same. That is, the instructor can be of two departments, but a department can have two instructors, or they can have only one instructor. So these are some constraints that we have to maintain while creating or defining the schema of a relation or a structure of a relation. Now, these are known as integrity constraints. So integrity constraints can be maintained while defining the schemas, or if the schema has been defined previously, we can alter it after the schema has been defined and now we want to update the schema, not the values in the database. Now we were talking about the constraints that is based on the data types or the attribute names, not the actual values. That is why we will consider all the data definition language or the DDLs, not the DMLs. So first we will talk about a single relation or a single record constraints that will consist of unique, not null, like this ones. So we will discuss it further with examples. Now in certain cases we want that the primary key cannot be null and we need to specify it. Other than the primary key, which is not null by default, we have some fields that is not meant to be kept null. So we can put a not null constraint while defining the schema of that particular attribute, or we can add it letter-wise that I have already told and drop it the constraint by the need of the changing database. And we can do this with the alter and add or alter or drop constraint command. First, we will create the defining schema part while creating and having an not null constraint. If the attribute is mentioned at the time of creation of the schema, then we can do it by the attribute name, the data type, followed by the size, and then mention the not null command here. So the not null will make the constraint that whenever the field name is kept null in some insertion, or there is some changing or deleting database on that purpose, so it will generate an error if the field is kept null on that purpose. So constraint is basically restrict the user to modify or insert data into a database that is being violated on that particular checking. Next, we will move to the unique constraint. See, as the not null constraint has to be put beside the every attribute, we can use the unique constraint as together, or other than we can put unique beside every attribute. Say for an example, the unique constraint defines that a data must be defined uniquely. So that, say the enrollment ID of a student, the employee ID of an employee must be unique from each other. So that is why if it is not in primary key, we should explicitly make it unique while putting it in the creation of schema or the updation of schema. See, the main difference between primary key and unique key is that on the primary key we cannot left any field null, but when maintaining the unique key we can keep any field null if necessary. So the unique key is put like So they are AI, AJ and AK are the attributes of a relation A, and we are making all the attributes a unique. So we can put it at the last of the creation, or the AI size then unique, AJ size unique, AJ size unique, AK size unique, like this. So it is generally wise to put it inside all, making a list of attributes as a unique. So the unique constraint make you insert a value that is not duplicated from another value of that attribute. Next is the check. The check constraint is also a single relation constraint that can put aside an attribute as well as a combination. So check is basically for checking some predicates while inserting or updating the database. Say I have mentioned in the earlier of the discussion that the budget of a department cannot be less than equals to 0. So when I am defining the attribute budget numeric, then I can put a check that is budget greater than 0. We can write it like that. So this I can put in the creation or updation of the schema to check that the budget should be always greater than equals to 0. So if I put 0 or any negative value in the budget field, then that will create an error and cause the integrity constraint violation. Now I can also put check in the set mechanism or a set member of domain. Say I can see that the city will be lie in always Kolkata, Delhi or Mumbai. So I can put the city field like in this. So this will make me check that the city I have typing in is either Kolkata or Delhi or Mumbai. No other than this. So I am taking a set of domain for a checking purpose. So now we will use this in a creation of schema on each of the case based on different scenarios. Now the next part of our integrity constraint is the referential integrity. Till now, I have talked about a single relation integrity constraint that defines that the constraint should be put only in the attributes of a single relation. And the referential integrity constraint checks with not one but more than one relations. Say for an example that I have created 3 relations separately. Now I want to make a relationship among these relations or tables. So I can make a primary key on a relation and then use that primary key as a foreign key on another relation. So making a foreign key from a primary key or a set of primary keys or a candidate key from a relation is known as the referential integrity or references integrity. This referential integrity helps us to define the relationship among 2 or more relations. So one relation can be used as a reference to one relation, another relation and one another relation. Or other than that, one relation can be related to another one, that can be related to another one, and that one in turn can be related to another one. So in this way, referential integrity helps us to build the chain relationship, hierarchical relationship among the relations. So let us see first that how to build the referential integrity in SQL. See, here we need to mention the attribute name, the size and data type of that attribute, then the keyword references, and then I am referencing which relation for referring this attribute. So the references keyword actually make the relationship and make this department name as a foreign key to this department relation. So I can see that I have put this relation name here after the references so that this reference name or the attribute name actually refer to some or one of the attributes in the relation department. So in this way we can put or use the referential integrity. Say for an example, if there is two relation R1 and R2, and K1 being a tuple of R1 and K2 being a tuple of R2, and there is attributes A1, A2, A3 of R1 and A4, A5, A6 of R2. Now if A4 references to A1, A5 references to A2 and A6 reference to A3, then we must have all K1 that is same of R1, K2 are of R2. So in this way we can define the referential integrity, that if the attributes are referencing to another attribute in another relation, then the records of pertaining that attributes must be exactly the same as of the referring relation. Now we will use all the integrity constraint and referential integrity constraints inside an SQL query. First, we will make the primary key constraint, that is the basic integrity constraint. See here what I have done. I have mentioned the building, room number and capacity as attributes of a classroom relation. And as to define a classroom, we need both the building and room number as a combination. So I am defining the primary key as the building and room number. So it is a combination of attributes, not a single attribute that we are considering as a primary key. If there is a single attribute as a primary key, we can write it beside the attribute size and data type. Next, we will use the check constraint inside a create. So here I am making a department relation with the name, building and budget attribute, or having the budget checked constraint with budget greater than 0. So whenever I want to insert or update the budget attribute of this database, so we need to keep in touch and keep it in mind of the check constraint of budget greater than 0. Next we will use the referential key integrity. See here I have used the not null constraint with name so that the name cannot be kept null while inserting or updating. So the last two constraints, that is, one is a primary key, I'm making the ID as the primary key, and now the department name that I have introduced, I am making it as a foreign key references to the relation department. See here I have used only one attribute. Even here I can use two or more attributes which can refer to the department. Now I can use this directly here as department name varchar 10 references department, but if I am referring it at the last of the creation, then I need to mention foreign key keyword and inside it department name as the attribute. Now I will show you the last example of the referential integrity referencing to more than one relation or a hierarchical and a chain relation. First, I am making a primary key as a combination of the course ID, the sec ID, the same and the year, because the section consists all of this. Next, I am using the foreign key references. See, the last two references I have mentioned two key features. One, we can use more than one foreign key, that is the CID reference to the course relation and the building room number combination refers to the classroom relation. Now, the next key feature is I have used a combination of keys as a foreign key that is referred to the primary key of the class relation. If you can relation or the remember class relation, we can say that the primary key consists building and room number both as a combination. So I am referring that primary key as a foreign key references here. So that is the referential integrity. Next, we will move to the other integrity constraints that present in the SQL queries. Now, when we talk about referential integrity, we need to keep in mind two things. That say if this is a referential integrity, so deleting something from section, say for a building number or a room number, we cannot delete it until and unless the particular tuple or a record or the attributes that we are referring to has not been deleted from the referring relation. So, if the classroom has got the primary key, building and room number, we cannot delete any tuple from the section relation, building and room number until and unless that particular condition has been satisfied with the classroom, and the deletion will be rejected because of the constraint violation. Because if the classroom has been deleted the relations attribute, then to whom the building and room number refer? So first we need to remove this constraint, and then only we can go to the removing actual classroom constraint. So after that we can name and rename the attributes, or we can remain it as the same one and delete the classroom primary key constraint. Otherwise, we cannot delete a referential integrity constraint if the primary key or the main referring relation still be present there. So that is one important aspect of the referential integrity constraint. Now, how to do the referential integrity constraint and make the delete a permissible one? We can use the delete cascade operation. The delete cascade same as the update cascade. What is an update? Update means the same goes with the referential integrity. Thus, even if there is a building room number updation on the reference part and not in the basic or referring part, then there will be a violation consideration and the update will be cancelled. So we can perform and delete cascade and updation cascade. The delete cascade and update cascade means that the deletion and updation will not be rejected if there occurs in any situation that the referenced relation is deleted first before the referring relation. So what will be done here? The deletion will be kept pending, and if there is a deletion later in any of the queries on the transaction where the referring relation is getting deleted on that attribute, after that cascading to the delete, the reference relation will be deleted. So here it will be not rejected at all, but also not done at that moment. It will be deletion on cascading delete of the referring relation. So now we can perform this delete cascade and update cascade by making a constraint adding to the references constraint. Now I am adding to the course that the department name is referencing to the department relation on delete cascade permission and on update cascade permission. So this will make not violating the constraint while deleting and updating the reference relation but not the referring relation at that particular moment. Now, while handling the transaction, checking and maintaining constraint become an important aspect. While conditioning a transaction that we say that should be an atomic and consistent one, if we make put this constraint violation available, that is by default known as initially deferred. So all the transactions are initially deferred by default, and after that we can make it deferrable or non-deferrable based on the condition of the transaction. Next, we will see some complex check constraints and another constraint that is known as an assertion. First, we will deal with the complex check constraints that will not deal with one attribute rather than more than one attribute or even a relation. So this is one example of a complex check constraint. In complex check constraint, the constraint is not having a single constant value checking rather than a set domain checking. We are having a select statement or a subquery inside the complex statement. So the check constraint statement consisting of the time slot ID, which I will check in not a set domain but a relation which I will get from this subquery by performing a select operation on time slot ID from the time slot relation. So first I am fetching all the time slot ID from the time slot relation and then check that the time slot ID belong to only that time slot IDs from the time slot relation. So in this way we can make the complex check relation. Now we will move to our next part, that is an assertion. You know, there are some check constraints that are always be true. Like a student cannot have a repeated or a duplicate enrollment ID of other students. So that is true for all the conditions, and that is not meant to be updated or not meant to be deleted and reused. So this type of condition checking or constraint checking is known as assertion. We can put this as assertions if there are something like conditions. Say the total credit of a student will be sum of all the credits that he has successfully controlled and completed by the semester. This is true. We cannot just change it. Or the instructor of a department cannot take class at two classrooms on the same building at the same time slot. One person cannot be present at two different areas. So this type of check constraints is known as assertion. That will be true in all the cases. And the assertions are meant not to be changed during the transaction or execution of query. If our assertion has been defined, it has to be kept like calling with the assertion name, and we can refer it by the assertion. So we will see that how to actually write and execute an assertion. So this is the syntax of creating an assertion, that we need to write create assertion, after that the assertion name, then use the keyword check, and then give the predicate or a set of predicates in the assertion. So first we will see an example where we can use the assertion. So we are creating an assertion named credits earned constraints that will check that the total credit of a student should be always same to the successfully completed, that he has not failed on any grade and an exam, and the summation of the credits. So we are checking first at the basis at the grade is not null and the grade is not equals to F. That is our basic checking. Now we are taking that the course he has taken as matches with the student ID. That means the student has taken the course. By natural joining the text with course, we can actually merge and see that what field is left null, and to check that if grade is not, that attribute or field that is kept being null in any case. Now after that we are actually summing up all the credit from the students. Now we are checking that there should not exist by the not exist checking constraint, that the total credits is not equals to this one. That means all the credits of the total one should be equals to this one. Other than that, the checking constraint will be violated. See why you are using the not exist other than exists. If we using the exist and put this equals to, there not is the violation checking. There is we are actually defining. But here the constraint is always against to be checked. That is why we have put not exist and a not equals to, that there should not be any field that is not equals to this. So all the total credits should be always equals to this. So this is all for the checking constraints and the integrity constraints and assertion. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.